Hello my dear students, welcome back to your channel. Hope you all are doing well. Today I am going to discuss all important questions of chapter 8, that is electromagnetic waves. First of all, you must know what do you mean by electromagnetic waves, or you can say EM waves. So electromagnetic waves are those waves in which both electric field and magnetic field changes continuously. In this direction, electric field is there. In this y direction, z direction, magnetic field is there. And this x direction, direction of propagation of wave. So electromagnetic waves are those waves in which electric field and this magnetic field changes continuously and are perpendicular to each other as well as direction of propagation of wave. This is diagram of electromagnetic wave. Now how this electric field and magnetic field created, right? So you know this oscillating charged particle produces electric field, and this oscillating electric field becomes a source of oscillating magnetic field, and this process continues because oscillating electric field and magnetic field act as a source of each other. Oscillating electric field produces magnetic field, oscillating magnetic field produces electric field. So both these fields acts as a source of each other, and hence an electromagnetic wave propagates in the direction of this E cross B. It means electric field is in one direction, magnetic field is perpendicular to electric field, and both direction of propagation of wave is perpendicular to this electric and magnetic field. This is diagram of electromagnetic field, right? Electric field is in x direction, magnetic field is suppose moving, this blue line shows magnetic field, this curve in z direction, then wave propagates perpendicular to this electric and magnetic field along x direction. So oscillating charged particle is the main source of electromagnetic wave. After that, you must know about electromagnetic wave spectrum. This is electromagnetic wave spectrum, right? Starting from this gamma ray, it is in the increasing order of wavelength. Wavelength increases and frequency decreases. It means gamma rays has minimum wavelength and radio waves are maximum wavelength, and also frequency decreases. It means gamma rays has maximum frequency, and maximum frequency means maximum energy. Gamma rays has maximum energy, radio waves have minimum energy. Now this is here wavelength is written from which rays to which range this gamma rays lies, then X-rays, then ultraviolet rays, then after that visible light, infrared, radio waves and microwaves. This visible light ranges from this 400 nanometer to 700 nanometer. Now you must remember this diagram and also wavelength region, frequency region, all these things. So after this, in this chapter, two important things are there. One is this electromagnetic wave and another one is electromagnetic wave spectrum. So now I am going to discuss all important 1 marks questions of this chapter, starting from this question number 1. What is this question number 1? Question number 1 is, do electromagnetic waves carry energy and momentum? What is the answer for this one? Guess the answer? Yes. Yes. Electromagnetic waves carry energy and momentum. Why electromagnetic waves carry energy and momentum? We already discussed that electromagnetic waves contains both electric field and magnetic field, right? Hence, there is non-energy density associated with it. And if energy density is there, it must have energy and momentum, right? Hope it's clear to all of you. Now, next question number 2. How is this speed of electromagnetic waves in vacuum determined by electric and magnetic field, right? So speed, you know, electromagnetic waves travel with the speed of light. If E naught, suppose E naught is peak value of electric current, B naught is peak value of magnetic field, right? Then speed of electromagnetic wave is related with these two as C equal to E naught by B naught. You must remember this formula also. This is the speed of electromagnetic wave and it is related with electric field and magnetic field in this way. Now next question number 3. Write the relation for speed of electromagnetic wave in terms of amplitude of electric and magnetic field. These are peak values of electric field and magnetic field. In this one, amplitude of electric field and magnetic field. So you can write that V equal to E by B, or you can write E equal to B V, or you can also write E equal to BC, because electromagnetic wave travels with the speed of light, right? So you must remember this formula also, E equal to BV. Now next question number 4. Question number 4 is, write the expression for speed of electromagnetic waves in a medium of electrical permittivity epsilon and magnetic permeability mu. You have to write the expression of speed of electromagnetic wave in terms of epsilon and mu. What is epsilon? Epsilon is electrical permittivity and mu is magnetic permeability. So the relation between these two is given as V equal to 1 by under root mu epsilon. If mu naught, you can also write it as C equal to 1 by root over mu naught epsilon. Mu naught is electrical permittivity in free space, permeability in free space. Epsilon naught is electrical permittivity in free space. If you know these two values, you can put these two values, you get a speed of light 3 into 10 to the power 8 meter per second. An electromagnetic wave travels with the speed of light in vacuum of free space, and general relation is V equal to 1 by root over mu epsilon. This is the permeability and permittivity of the medium. Now next question number 5. What are directions of electric and magnetic field vectors relative to each other? Electric and magnetic field vectors are mutually, we already discussed these things, mutually perpendicular to each other. Yes, na? Mutually perpendicular to each other, and also relative to direction of propagation of electromagnetic wave. Suppose electromagnetic wave is in this direction, electric field is this direction, and magnetic field is in this direction. This is X, Y and Z. So if this electric and magnetic field are perpendicular to each other and both are perpendicular to direction of propagation of electromagnetic wave. So this is the answer. Next, question number 6. In which directions do the electric and magnetic field vectors oscillate in electromagnetic wave propagating along the x-axis? This is the direction of electromagnetic wave, x-axis. So electric field and magnetic field are oscillating along which direction? Along y-axis and z-axis. Yes, na? Along y-axis electric field and z-axis magnetic field. Then in x direction wave propagates. Hope it's clear to all of you. Next, question number 7. Question is, a plane electromagnetic wave travels in vacuum along z direction. Now again the same diagram. Wave is traveling along, suppose this one is x, this side is y, and this one is z. Now this time wave is traveling along z direction. This direction wave is traveling. It means electric and magnetic field are along x and y direction. So you can write it as direction of this electric and magnetic fields are along y and x axis if wave is traveling along z axis. Hope it's clear to all of you. Next, question number 8. The speed of electromagnetic wave in a material is given by V equal to 1 by under root mu epsilon, where mu is permittivity of the medium, epsilon is permittivity. How does its frequency change? Velocity changes with the medium. How is its frequency change? Yes, please guess the answer. Yes, frequency will remain same. It does not change with the medium. It will remain same. You must remember this point, very, very important. Okay. Now next, question number 9. A capacitor has been charged by a DC source. What are the magnitudes of conduction and displacement current when it is fully charged? Okay. When the capacitor is fully charged, no current will pass through the capacitor. Okay. So what happens? Both conduction current as well as displacement. Suppose IC is the conduction current and ID is displacement current. Both are zero when it is fully charged, because the circuit will act like an open circuit. So the value of conduction displacement current is zero when the capacitor is fully charged. Now next, question number 10. Question number 10 is, plane electromagnetic wave travels in vacuum along y direction. What can you say about direction of electric and magnetic field vectors? This come in the year 2011. Now here electromagnetic wave traversing along y direction. If wave is traveling along y direction, the direction of magnetic field and electric field is along, yes, x and z direction. This is the direction of electric field and magnetic field if wave is traveling along this y direction. Hope it's clear to all of you. Now next, question number 11. Question number 11 is, name the physical quantity which remains same for microwaves of wavelength 1 millimeter and ultraviolet radiation of 1600 in angstrom in vacuum, right? So which quantity is same? Microwave of wavelength 1 millimeter and ultraviolet radiation of wavelength 1600 angstrom. Which quantity is same? Guess the answer. Yes. Fast. Yes, speed remains same, right? If both wave, microwave of wavelength 1 nanometer and ultraviolet radiation of wavelength 1600 nanometer in vacuum, then which quantity remains same? Wavelength is different, but speed remains same. It does not depend on the medium, or right? Now next, question number 12. The charging current for a capacitor is 0.25 ampere. What is displacement current across its plate? You know, displacement current ID is always equal to conduction current. Here, conduction current is what? Charging current 0.25 ampere. So, displacement current ID is also equal to 0.25 ampere. This is the answer of this question number 12. Right? Now, hope it's clear to all of you. Next, question number 13. Question is, write two uses of X-rays. Okay, X-rays has shorter wavelength and very high frequency and also high energy. So, first use of this X-rays is it is used as a diagnostic tool in medicine, right? Diagnostic tool in medicine. What is second use? Yes, it is used in the treatment of certain forms of cancer. Okay, these are two uses of X-rays. Now next, question number 14. Name the radiations of electromagnetic spectrum which are used in warfare to lock through fog. Yes, which radiation is used? Guess the answer. Yes, fast, very good. Yes, infrared rays. Infrared rays, right? Now next, question number 15. Why are microwaves considered for radar system used in aircraft navigation? You know, microwaves has very shorter wavelength, right? It has very shorter wavelength of the order of few millimeters. So due to its shorter wavelength, they are not diffracted easily. They are not diffracted very easily, right? And can travel longer distance, right? Now travel longer distances. Okay, now hope it's clear to all of you. Next, question number 16. Question 16 is, give reasons for the following. The small ozone layer on top of stratosphere is crucial for human survival. Why? Because it absorbs a large portion of ultraviolet radiation which is harmful for living organisms, right? Ultraviolet which is harmful for living organisms. Right now, so the small ozone layer on top of the stratosphere is crucial for human survival because it absorbs large portion of ultraviolet radiation which are harmful for living organisms on the earth emitted by the sun. Hope it's clear to all of you. Next, question number 17. Which part of electromagnetic spectrum has largest penetrating power? Which has shorter wavelength and high frequency? That is, yes, that is gamma ray. Gamma radiation has high penetrating power. Next, question number 18. Which part of electromagnetic spectrum is absorbed from sunlight by ozone layer? Same question number 16. Which part is absorbed? Yes, ultraviolet ray. Right? It is absorbed by the ozone, small ozone layer on top of the stratosphere. Next, question number 19. Question number 19 is, name the electromagnetic radiation used to destroy cancer cells and write its frequency range. Already discussed. Cancer cell. Which electromagnetic radiation is used to destroy cancer cell? Yes. Yes, gamma rays. Right? And what is its frequency range? Its frequency range is in between 10 to the power 18 Hz to 10 to the power 22 Hz. Right? Now, next question number 20. To which part of electromagnetism do the waves emitted by radioactive nuclei belong? What is its frequency range? Again, the same question, but form is different. Here again, answer is gamma rays. Gamma rays are emitted by radioactive nuclei, right now, and its frequency range is again 10 to the power 18 Hz to 10 to the power 22 Hz. It has very high frequency, very high penetrating power. It is used to destroy cancer cells, right? Its frequency range is between 18 to 22 Hz. Now, next question number 21. Which part of electromagnetic spectrum is used in satellite communication? Which has yes, larger wavelength. So, which electromagnetic spectrum is used? Yes, microwave. Microwave is used in satellite communication. Now, after this, next question number 22. 22 question is, name the electromagnetic radiation used for water purification and eye surgery. Yes, in both cases, which electromagnetic radiation is used for water purification and eye surgery? Please guess the answer. Yes, fast. Yes, ultraviolet rays is used in both the cases. For water purification also ultraviolet ray is used, and for eye surgery also ultraviolet ray is used. Next, question number 23. What is the frequency of electromagnetic waves produced by oscillating charge of frequency nu? The frequency of electromagnetic waves produced by oscillating charge of frequency nu is same as that of electromagnetic wave. Right? So, hope it's clear to all of you. Next, question number 24. To which part of electromagnetic spectrum does a frequency of 5 into 10 to the power 19 Hz belong? Yes. To which range this frequency range belong? Yes. Again, gamma ray. In gamma rays, frequency range is between 10 to the power 18 Hz to 10 to the power 22 Hz. And here it is given frequency region 5 into 10 to the power 19 Hz. So, answer is gamma rays. Next, question number 25. Yes. To which part of the electromagnetic spectrum does a frequency of frequency 3 into 10 to the 13 Hz belong? Yes. In which region this frequency range belongs? Which part of electromagnetic spectrum? 10 to the 13 Hz? Yes. Again, what is the answer? Yes. Infrared region is the answer, right? Infrared region. You must remember frequency range, wavelength range of all the electromagnetic spectrum. Okay, whole electromagnetic spectrum, gamma, infra, micro, ultra, visible, everything. Now, next question number 26. To which part of the electromagnetic spectrum does a wave of frequency 5 into 10 to the power 11 Hz belong? 10 to the power 11. Answer is again, which electromagnetic spectrum? Yes. Yes, microwave, right? Microwave belongs to this frequency range 5 into 10 to the power 11 Hz. Microwave region is 10 to the power 9 Hz to 10 to the power 11 Hz. So, this region belongs to microwave, right? Now, next question is, name the part of electromagnetic spectrum whose wavelength lies in the region of 10 to the power minus 10 meter. Guess the answer and also write its one use. Yes. Yes. Again, 10 minus 10 means which electromagnetic spectrum? Yes. Again, yes, gamma rays. Gamma rays comes under this region, 10 to minus 10 Hz. And write one of its use. What is its use? Gamma rays, yes. Gamma rays are used in many places. These are used in radiotherapy also. Radiotherapy. Therapy. One use only, right? Radiotherapy for treatment of malignant tumors. Okay. Now after this, next question number 28. Arrange the following in descending order of wavelength. One question is this one, question 28, and after that question 29 is arrange these waves in the form shortest wavelength. So first this one, arrange the following descending order of wavelength: X-rays, radio waves, blue light and infrared. In the descending order of wavelength, it means which one has highest wavelength? Yes, very good. Which one has highest wavelength? Radio waves, yes. Radio waves have highest wavelength than infrared ray. Again, then, yes, from here blue light, right? And then again, last shortest wavelength, X-rays. X-rays are shortest wavelength and highest frequency, like gamma rays. Now, so this is the region. Radio waves have greatest wavelength from all these to four. Then infrared shorter than infrared is blue light, and shorter than this blue light is X-rays. Now last 29 is which of the following has a shortest wavelength? Microwave, ultraviolet, X-rays. From all these three, which has shortest wavelength? Yes, X-rays has shortest wavelength. It has highest frequency, like gamma rays and hyperactive power. So among all these three rays, X-rays has shortest wavelength. So with this, I am going to end my class. Hope you like this 1 marks question series of this chapter. Like this one, we will cover other chapters also, right? Up to then, students, keep revising and stay tuned with this channel. Thank you.